Day 10, solving rational equations and inequalities. Today you will be able to solve more rational equations and inequalities. Remember, a rational equation is an equation that contains one or more rational expressions. Eliminate your fractions by multiplying by the least common denominator. Be sure to check for your extraneous solutions. Looking at example 1, we want to make sure and factor all of our denominators. So when we factor x squared minus 2x minus 3, we get x minus 3 times the quantity of x plus 1. Right here we have 3 minus x. So we want to make sure and factor out a negative 1. When we factor out a negative 1 in that fraction, it becomes x minus 3. This negative 1 and this negative up top, we can cancel out and we can leave it x over x minus 3. If you want to bring your first ratio down, it'll help you keep things organized and clear. And then we have 1 over x plus 1. So now is where we're going to look for our missing pieces. We have an x minus 3 in our first term, an x minus 3 in our second term. We're missing an x minus 3 in our last term. We have an x plus 1 in our first term. We have an x plus 1 in our last term, and we're missing an x plus 1 in our middle term. After all of our denominators are the same, we want to check for our extraneous solutions. So set x minus 3 cannot equal 0. X plus 1 cannot equal 0. So x cannot equal negative 1. X cannot equal 3. And then after we do our extraneous solutions, we can get rid of those denominators. So we have 4 is equal to x times the quantity of x plus 1 minus 1 times the quantity of x minus 3. It's really important to rewrite this so you don't lose any terms. 4 is equal to x squared plus 1x. Negative 1 times x is negative 1x. Negative 1 times 3 becomes a positive 3. So a common error is a negative times a negative. Sometimes we forget that's a positive. X squared, 1 minus 1 cancels out. 3 minus 4 is negative 1. So x squared minus 1 is quantity of x minus 1 times x plus 1. Set x minus 1 equal to 0. We get x is equal to positive 1. X is equal to negative 1. We know we have an extraneous solution of negative 1. So our solution is just x is equal to 1. When we look at example number 2, make sure you factor all your denominators, x minus 1, x plus 1. X squared plus x minus 2 factors to x plus 2 times x minus 1. Find your missing pieces. We have an x minus 1 and x minus 1. We have an x plus 1. We're missing an x plus 1. We have an x plus 2, and we're missing an x plus 2. Once your denominators, you have all your denominators written. Remember, you want to find your extraneous solutions. So x plus 2 cannot equal 0, x minus 1 cannot equal 0, and x plus 1 cannot equal 0. So x cannot equal negative 2, 1, or negative 1. You can then cross out your denominators, distribute your numerators. X plus 2 is equal to 2x plus 2. So subtract your 2, you get 0. Subtract your x, you get x is equal to 0. It's not one of your extraneous solutions, so you're finished. Example number 3. Again, this middle one, you want to make sure and factor out a negative. So you can rewrite your center term. So you have 2 over x plus 1. Factor out that negative so you can attach that negative to your numerator, and it's going to become x minus 1. And then your second fraction, factor your denominator x plus 1, x minus 1. So find your missing pieces. X plus 1, x plus 1. We're missing an x plus 1 in the center. X minus 1, x minus 1. We're missing an x minus 1 in our first term. Find your extraneous solutions. X cannot equal positive 1 or negative 1. Cross out your denominators and finish your problem. 2 times x minus 1 plus negative 1 times x plus 1 equals negative 2. 2x minus 2 minus x minus 1 equals negative 2. 2x minus x is 1x. Negative 2 minus 1 is negative 3. Equals negative 2. Inverse of negative 3 is plus 3. X is equal to 1. Except we know that x can't equal the 1. So if your solution and your extraneous solution match, and it can't be a solution, you have no solution to your problem. The last thing that we want to take a look at is a word problem. So alpha and beta mow lawns together. Alpha working alone can complete a job in 4 hours. Beta can complete a job alone in 3 hours. So alpha alone can complete 1 job in 4 hours. Beta working alone can complete 1 job in 3 hours. Okay, how long does it take them to complete the job together? Well, if we take alpha and we add beta, how long does it take for them both combined to complete 1 job? So we do 1 job in the numerator over how long or the time. So t cannot equal 0 for our extraneous solutions. We are missing a 3 in this numerator. We are missing a 4 in this numerator, and we are missing a 3 and a 4 here. We are missing a t, and we are missing a t. Your denominators all match. We have 3t plus 4t is equal to 12. 3 plus 4 is 7t. When we divide by 7, we get our time is approximately 1.7 hours to complete the job.